Hello everyone. My name is Prajapati, the supervisor of Professor Raghubir Kumar, Department of Physics, Institute of Science, Varanasi University. And my topic to study DC conductivity dielectric property of composition PVA, CS, PG, AgNO3 based biopolymer electrolyte film. Outline, introduction, motivational, material and sample preparation, characterization, conclusion, references. Introduction. The role of biopolymer blend electrolyte based PVA, CS, PG, AgNO3 in weight percent 0, 10, 20, 30, 40 in weight percent of respectively. The sample were prepared by using the solution of the cast technique method. This is a method, a very useful method. Biopolymer blending, one of the promising the approach to enhance the ionic conductivity, mechanical flexibility, and optical property of the electrolytes. Motivational to study the high ion conducting plus size CS based biopolymer polymer electrolyte and the ionic transport property of the prepared the electrolyte in terms of DC conductivity, AC conductivity, dielectric property, and electric modulus in study of the very useful characterization. Biopolymer cost of the effective non-toxic, natural, evident, renewable, the eco-friendly, and can be easily obtained from the natural source such as cell was the plant, animal. In this synthesize the biopolymer high cost material compared to the natural abundant renewable the biopolymer such as chitosan, starch, cellulose. First figure is shows the chitosan in a powder form. Now the second figure showing chemical structure of chitosan. Property of the chitosan: linear polysaccharide and chelating and flexible property and good film forming properties. Preparation of biopolymer in electrolyte. There is a method, very useful method, a solution of the cast technique method, and use the prepared the film. Chitosan plus acetic acid start 2-3 hours. Then after PGA, PG start for 2 to 3 hours. Then added salt in weight percent 0, 10 to 20, 30, 40 respectively. Then after stirred for 48 hours. Sometime viscous the solution of the chitosan PBA AgNO3. The viscous solution were pure the impacted discs and dry 72 120 hours at a room temperature to freely stand the polymer electrolyte film. First figure is showing film without AgNO3. Now second figure show the 30 weight percent AgNO3. Because of the AgNO3 react to the acetic acid, this that is a produce in the black color also. Next, characterization technique, impedance spectroscopy technique. Impedance spectroscopy technically studies the electrical conductivity and ion dynamics, the behavior of the mobile change present in the polymer electrolyte system and their interface. RB indicates that the bulk resistance RB equal to rho P upon A. P is the film thickness, A is the area. Ionic conductivity. Ionic conductivity Nyquist plots give the semicircular plot showing the high range of the resistance and the intercept of the real axis give the bulk resistance. First figure shows the depend upon the concentration dependent, but now second figure show chitosan at a 30 degree centigrade for a different temperature. Temperature dependent conductivity and relaxation frequency. Temperature dependent conductivity relaxation frequency. So the concentration dependent frequency or relaxation frequency frequency dependent 1000 upon T per Kelvin. AC conductivity show the figure the three region: low frequency dispersion region, mid frequency region, plateau frequency region, and high frequency region. Variation of the AC conductivity with the frequency for in a weight person AgNO3 0, 10, 20, 30, 40 at 30 degree. Now figure B, biopolymer based electrolyte film at a different temperature respectively. Now table the different amount of AgNO3 so that increasing the DC conductivity but decreasing the activation energy. Dielectric permittivity. Dielectric first figure shows real part. Now second figure B show the real part, also real part, and C and D so showing the imaginary part. Biopolymer based film at a different temperature is noted that the epsilon double dash electrolyte system first decreasing with the increasing frequency. Electric modulus study. Electric modulus study is the variation of the electric modulus with the frequency for A, figure A and C, biopolymer 1 to biopolymer 5 sample with the different composition of CS at 30 degrees centigrade, and figure B and D sample, B and C sample biopolymer based electrolyte film at different temperature. This is so the complex dielectric modulus structure of the used very frequency understand the conductivity relaxation. The real M dash is a real and imaginary M double dash part of the completion. Now next ionic transference number measurement. Generally, ions are the active space is the biopolymer based electrolyte figure show the ionic transference number. Plot the ionic transference number. Observe the optimum the sample was 0.99 that the show the ionic nature in dominate in this system. Our optimized sample 38%. Ionic transformation easily calculate this formula. Ti equal to I is the initial minus I final upon I initial. Linear sweep voltammeter LSB analysis. It is was to determine the electrochemical stability window of an electrolyte. Figure show the LSB plot the optimized sample at a different scan rate. The operation voltage of biopolymer based electrolyte has been observed minus 1.5 volt to plus 1.55 volt. Conclusion: 10 CS 19 PVA 20 PZ with the X weight person AgNO3 X is equal to 0, 10, 20, 30, 40 based the blend biopolymer electrolyte has been prepared using solution the cost effective method. The sample biopolymer based electrolyte show the optimum ionic conductivity 1.7 into 10 to the power 4 Siemens per centimeter at a 30 degree. References and thank you.